this is a talk about some of the things that can go wrong when you try to run computational experiments on modern hardware. In constraint programming, we often rely upon empirical evaluations to determine whether a new algorithm or solving technique is any good. And if a new solver runs 10 times faster than the previous state of the art, then that's fairly easy to demonstrate. But what if we're looking to do something more subtle? For example, if we are looking to determine the effect of a small change to a solver's source code, we might be looking at a performance difference of only a few percent. And this can be something that's very hard to measure reliably. And most people know that modern hardware can sometimes be a bit weird and a bit badly behaved. But a lot of people underestimate just how big the problem is. That there is a general assumption that hardware is deterministic, so if you run the same experiment with the same solver on the same hardware, then, for example, runtime is something that you can just measure. In this talk we're going to go into a bit more detail and show that this really isn't the case, that, for example, runtime is not something that you can just treat as a deterministic measurement. Our contributions in this paper are to revisit the approach we take to empirical experiments for combinatorial solvers, and to illustrate some of the aspects of uncertainty that arise in modern hardware. We give an overview of some standard measures, their effects and potential errors, and some biased suggestions for useful tools when running experiments. We also look at the feasibility of carrying out experiments when you only have limited access to hardware. In particular, we're not saying that everybody needs to run perfect experiments all the time. What we're saying is, if you're in a situation where you don't have access to a carefully calibrated experimental setup, then you should be aware of how large the errors can be and how this limits what type of experiments you can carry out.